Okay, we're taking a look at question 12 from your calculus practice exam for chapter 10. It says to write out the first four terms and the general term for the Taylor series centered at a equals 0. Usually we like to say that c equals 0, but it doesn't particularly matter. Everything is functional the same way. So I've started off with the series for cosine x, and the next thing I'm going to do, as you see over here, is we're going to substitute x squared over 2 into our series. So let's go ahead and put in x squared over 2, and let's see what happens to our series. X squared over 2, 1 plus, I'm going to take that 1/2 and I'm going to move it to the front because this x squared over 2 is going to create a compound fraction, which we are trying to avoid. I see I made my first mistake already. That should be a minus. And then we got plus 1 over 4 factorial. 4 factorial is 24. Definitely no need for you to simplify that out, but I thought I'd do it anyways. X squared over 2 to the 4th power plus, no, minus, I keep making that same mistake, minus, now 6 factorial I'm not going to bother with. I think it's 720. Yeah, I'm not even going to think about it. 6 factorial x squared over 2, the whole thing to the 6th power plus, and then here we're going to have to deal with the general term. Okay, so as you can see, I've taken that -1 to the n, put it on top of the 2n factorial, just to make way for the x, so I don't have to put a compound fraction on this one either, to the 2n. Okay, so that looks pretty good. Yes, I think I am going to simplify this. Cosine of x squared over 2 equals 1 minus, same error again, minus 1/2. Okay, 1 over 2 squared times 1 over 2 squared. I think I'm going to return this to a factorial actually. 2 squared x to the 4th power plus 1 over, I'm going to return this also to a factorial. And this is 2 to the 4th power. Good reminder for you that it's not always necessary for you to multiply that power out. And that's x to the 8th power minus 1 over 6 factorial, 1 over 2 to the 6th power, and then x to the 12th. And then plus, okay, and let's see. Let's put all of this underneath that -1 to the n power, 2n factorial, and then that's 2 to the 2n power, and then x to the 4n power. I don't know why I put that in parentheses. It's not really necessary. Okay, so that is almost finished. This is definitely the most unwieldy series that we work with. We're going to multiply everything by x, and that should give me my series for f of x. So x cosine x squared over 2. All right, so we're going to multiply each of these by x. So 1 times x is, of course, x. Copy down this coefficient, and that's going to be x to the 5th power plus 1 over 4 factorial 2 to the 4th power. I almost wrote 24. X to the 9th power minus 1 over 6 factorial 2 to the 6th, x to the 13th. And then, you know, my favorite general term. Let's see, that's -1 to the n 2n factorial 2 to the 2n power, and then now this is x to the 4n plus 1. Yeah, that is super unwieldy, not particularly beautiful looking, but there's our series, an exercise in torture probably. All right, let's take a look at question 4. Let's find the first 4 terms in a general term for the Taylor series. If we take the derivative of this, okay, well that's just the derivative of every term, f prime of x, that's going to be equal to, well, I don't need to take the derivative of the sum, so I just need to take the derivative of all of these guys over here. Take the derivative of all of that. Now, when you take the derivative, the only thing you need to take the derivative of is anything that has an x. All the other stuff, not necessary to take a derivative. Those are all constant in terms of our derivative. So really, when you take the derivative, it's kind of a exercise that comes straight out of calculus A. All right, let's get rid of all that yellow mess and start our work. Are we getting rid of the yellow mess? Yeah, we are. Okay, the derivative of x is 1. That was funny. The derivative of x is 1 minus, and I'm going to try to compact this. The derivative of x to the 5th is 5x to the 4th. I'm going to take that 5 and multiply it with a 1. And that's just going to be x to the 4th now. Plus, same thing here, I'm going to take that 9, put it up on top of the fraction, bar, 4 factorial 2 to the 4th, and now x to the 8th power, minus, similarly, that's 13 on 6 factorial 2 to the 6th, x12 plus, and boy, is this going to look ugly. Negative 1 to the n power, 4n plus 1 in parentheses, because algebra fail is a thing, 2n factorial, and 2 to the 2n power. And if I lose a power from 4n plus 1, I just get to the 4n power. Not a whole lot to do. I think that looks better. So do I have 4 terms in a general term? 1, 2, 3, 4 terms, general term. I'm looking good. Let's move on to letter C. Okay, so now we're supposed to take the the integral of f of t. Let's see, can I copy and paste f of t over? Or f of x? Should be able to. Let's lasso. Ooh, that is nice. Copy. Let's go down to letter C. There's my C. And let's paste. Oh, that's not it. Paste. Yeah. Amen. Okay, so just like before, all the other stuff that's not an x is just going to be constant. No need to actually integrate it. The only thing you need to integrate is the x's, which confusingly we're going to turn into a t now. So we're going to integrate from 0 to x. We're going to take that same polynomial, replace all our x's with t's. So that's a t minus 1 over 2 factorial 2 squared t to the 5th power. And let's continue writing that. Yeah, it's asking for the general term. I did a check there. You definitely want to make sure that the general term is needed because it is kind of a pain to work with. Not necessarily difficult to work with, just a pain to work with sometimes. dt. Okay, so I think I got it. That's every term. Let's integrate. All right. Raise the power, divide by the new power. So 1/2 t squared, certainly, minus, and what we'll do here is, since we're going to be dividing by our new power, I'm just going to actually put that new power underneath this fraction bar just to save us a little bit of space here. So 2 factorial, 2 squared. 5 plus 1 is 6, so we'll put the 6 down over here, make that t to the 6. And we're going to do that all the way down the line. 1 over 4 factorial, 2 to the 4th. 9 plus 1 is 10. So we'll multiply by 10, and t to the 10 minus 6 factorial, 2 to the 6. 13 plus 1 is 14. So we'll multiply by 14 and get a t to the 14th. And then for everyone's favorite, the general term, negative 1 to the n, quantity of 2n factorial, 2 to the 2n, and then 4n plus 1 plus another one is 4n plus 2. And then we'll multiply that by t to the 4n plus 2. Right bracket that from 0 to x. And that's the whole process of integration. The next part is just to substitute. Let's see, if I substitute an x, magically all the t's will just turn into an x. Or maybe I just should say naturally. All the t's will just turn into an x. 2 factorial, 2 squared times 6, x to the 6. And I bet you're probably tired of listening to me just say what I'm writing. You ever get tired of hearing your own voice? Don't worry, you're not alone. All right. Negative 1 to the n, 2n factorial, 2 to the 2n, 4n plus 2, and our good friend x to the 4n plus 2, minus, and you could probably see that if you turn all of the t's into 0, you're just going to get a 0. So you can write that 0 in there, you can leave it off. Doesn't particularly matter either way, but I'm just going to write it in there. And that is our integral. And that's all 3 parts of question 12. And we'll be back for question 13.